I'm going to talk to you about the future of front-end performance. I'm really excited to talk to you about this. It's one of my favorite topics, and hopefully it's not boring for you. So my name is Karamalegos. As Reg mentioned, I am from New Orleans, so this is me at Mardi Gras with one of my friends, and I'm a developer, but this picture is more interesting than the developer stuff. But I'm also half Greek, so why is my name so long? That's why. So does anyone know why elevators have mirrors? Does anyone know? Yeah, well, I'll just answer for you. But so some people think it's so that you feel like it's bigger, because it makes it less claustrophobic. But what happened was, a long time ago, people were really frustrated because it felt so slow, like waiting for the elevators and being inside the elevators. But it's really expensive to install more elevators or make them faster, at least in the old days. So what they did is they put mirrors in there, and people were suddenly distracted by their own narcissism, as I say it. So the mirror's in there, you're like, oh, and you're doing this stuff, and you're not distracted by how long it takes. So I just want you to keep that little story in the back of your head while we talk about performance. So why should you even care about performance? Well, there's real-world advantages to making your website more performant for users. So for example, at Pinterest, they increased their performance, which resulted in a 15% increase in SEO traffic and a 15% increase in conversion rate to sign up. AliExpress, which is kind of like the Amazon in Asia, they reduced their load time by 36% and saw a 10.5% increase in orders and a 27% increase in conversion for new customers. So that's bottom line impact. This is getting you more money to your company or your client, depending on what role you are as a developer. Why else should you be interested? So now for Google search, speed is now used as a ranking factor for mobile searches. So if your website is too slow, you're not going to be ranked very high in search. So before we even talk about what are the things you can do to make your website faster, let's talk a little bit about measurement and analysis. Does anyone know what the Pareto principle is? It's also called the 80-20 rule. So it says roughly 80% of the effects come from 20% of the causes. So does that mean you should optimize every single thing? No. So what you should do is you should measure it and be lazy. Only optimize your worst offenders. So we don't pre-optimize or over-optimize. Just do the worst offenders and start from there, like this lazy puppy. So which metrics matter? Traditionally, we're always concerned about load time. But when you think about load time, it's not necessarily have you ever opened DevTools and run it with screenshots, the record with screenshots? Sometimes when it says on load is not necessarily when the page is visually relevant to the user. So there's this other metric called speed index. I'm going to go into these in a little bit more detail in a second. Time to interactive. So not just the load, but when can I start using the page? And then jank and responsiveness, which is actually it's related to time to interactive as well. So when you think about you're on a page, it's loading, you're trying to scroll, but it's not working properly, or you're clicking in an input and it's not working correctly. Let's look at these in detail. So speed index measures how quickly the page contents are visually populated. So when is the page visually significant? It's expressed in milliseconds. A good rule of thumb is about 1,200 milliseconds is a good page load time, or speed index load time. It's dependent on the size of the viewport, so what the user can see, or what you might call above-the-fold content. So it's very dependent on the user. Webpagetest.org is my favorite tool to measure this and to actually do a lot of performance analysis in addition to DevTools. I believe Lighthouse in Chrome also has a speed index measurement now using a node module called Speedline. So time to interactive. let me start this thing, this little video, so you can see a visual representation of it. Oh wait, that's on the wrong thing. 2 screens. So time to interactive. You can see the left side has showed up quicker, but we're clicking, nothing's happening. We're starting to get a little frustrated. We're starting to get more frustrated. We're clicking, and then finally, on the right side, it starts interacting. So that's really what time to interactive is. It's that time when the website is finally useful. Oh, I think my clicker is confused. All right. And then jank or responsiveness. So the frame rate, or frames per second, is one measure of responsiveness. Modern devices refresh their screens at about 60 frames per second. So this top line isn't 60, it's 50, but it's close enough. So if we convert that to an individual frame, we theoretically have 16 milliseconds to render, but the browser actually needs some of that time. So when you're thinking about re-renders, you should really only target 10 milliseconds for your re-renders or your frames. Any more, and the human eye can actually see that visual jank, which you can see here. You know, like as my frames per second goes lower, we can actually see that jankiness. So how do we actually, what are some ways we can measure these things? So synthetic testing is like your traditional, I'm like, come on, you can do it. Let me try refreshing this. Oh, well, it's not working, but it's not that important. So this is the network tab in DevTools. And so we use the network tab in DevTools, or we can use web page test. And this is what we do to optimize load and speed index. You can also optimize specific other events by clicking start before you do something and then stop at the end of it. So these are a synthetic testing way to measure load and speed index. And then when we think about responsiveness, we usually use the performance tab. So I want you to just stop for a minute, absorb what's going on here, and I want you to think about, how does this make you feel? Does what's happening on this screen make you a little bit nervous or uncomfortable? Do you actually know what's going on this screen? So I feel like as developers, sometimes we kind of avoid learning DevTools to our most potential because we have other things to do. So if you take one thing from this presentation, I want you to go home and really focus on learning more about how to use DevTools effectively, because it makes your job as a developer easier. Because like I said, you only want to optimize the worst offenders. So you don't know what those worst offenders are until you know how to effectively use your measurement tools. So that was synthetic testing, but there's a way to do real user monitoring, or RUM. This is the less fun RUM. But there's these cool APIs you can use. There's the navigation timing API and the resource timing API, and those will automatically do some measurements for you. I'm really excited about the user timing API also. Don't worry about trying to copy down. I don't expect you to copy down that whole URL right now. I will share the slides with you, and also all the links to all these resources and additional resources so that you can learn more afterwards. But the user timing API is really cool. So for example, say you have a blog post or a blog application, and in your head you're like, okay, well, what's the most critical thing for load on this page? Like, when will a user be happy? Maybe it's when the heading shows up, like the heading for the blog post. So you can actually use the user timing API to put in a manual a manual flag of when that heading has rendered. So you can actually get like really accurate timing on specific things. I wouldn't overuse this, but it's really cool because you can get like actual real user monitoring. You can send it to like Google Tag Manager or whatever so that you can get the real timings from your real customers or users. All right. So the other thing we should do, and there's kind of a moral implication of developing for our end user. So what kind of computers do you have? Like, what kind of computers do you develop on? You probably have like a MacBook Pro or something like that. What kind of networks or what kind of phones are in your pocket? I have a Pixel 2. I don't know, maybe you have the iPhone 10 or X. What is it called now? I don't even know anymore. So when it comes down to what people have in the real world, we usually have devices and networks that are a lot faster than our end users. So there can be a 2 to 5x difference in the fastest versus the slowest phones, like just the processing power of the phone itself. 75% of worldwide mobile connections are on 2G or 3G. I think like 45% is just on 2G. That's a lot slower than most of us are used to. But it's not even that. Like, say we're in a highly developed area. For example, my mom, she lives in rural Texas. And so she can't get a high-speed internet connection directly at her home. She has to get like the mobile broadband thingy and connect via that. So she's actually paying for her data by bytes. And then, like, for example, you're at a conference and you have spotty Wi-Fi. This happens. This is like real-life stuff. So you still need to be concerned about speed, and you need to measure and analyze your website according to the speed of your users, not the speed of what you usually have. So there's some cool tools. You can use webpagetest.org, and you can actually, so look at your Google Analytics data for your application, and try to use the same profile. You can set up a profile in webpagetest.org to kind of mirror those users. Like, for example, Google does I think it's actually webpagetest.org/easy, and it's their default settings of what they do for their management. Of course, not all of us have a Google worldwide audience, but theirs is like a $200 Motorola phone, and it's on a fast or slow 3G network. So you can actually set up the profiles to be a certain speed and region. And then from there, you can also set up performance budgets. So say your website is, on average, your users have this phone and this network, and you want to target maybe a 5-second load initially and maybe a 2-second load on visiting the page again. So you can set up a performance budget from there. So like, for example, theirs is like 140 kilobytes to 170 kilobytes, I think, gzipped. And then you can set up a performance budget using Webpack. I think Prepack would do this too. I think this thing fell asleep. So now let's dive into performance. Does anyone know what like the most bytes traveling on the internet are? What they're from? What it's from? It's images. So images account for 60% of the bytes on average needed to load a page. So my talk is not mostly about images, but I feel like because they're such a big chunk of the volume on the internet, I want you to know a few things about images. And I know this quote does not look legit because it just says Google, because it's on like one of their generic web page docs, and also in one of their tutorials like on Udacity. But it is a legit quote. So what's your image optimization toolbox? Well, you want to learn how to use the right image type for your situation. For example, PNGs versus JPEGs. Like, for the most part, JPEGs are smaller, and you really shouldn't use PNGs unless you actually need like transparency or something like that. You want to use the right size for the view, of course, and source sets. There are Webpack loaders that let you auto-build these source sets. And then compressing images, like with a tool with Image Optim, if you're doing it manually, But you can set up your bundler to do this for you as well. There are some really cool tools. So it's really not a lot of work in order to do these optimizations. And they'll strip out like the image metadata, but also do compression. And you can, it comes with default settings, but you can also, if you're really concerned about the images yourself, you can put in custom configurations in order to do the setup that you want for each image type. And I provide some tools for how you get started with those. So what's our most expensive asset? Are all assets created equally? No. JavaScript is our most important asset, or most expensive asset. Some of you might have seen this. Adi Osmani does a lot of talks and articles about performance, and this is one of my favorite ones. I know it's a little bit small, but so I'll just explain it. But say we have 170 kilobytes of JavaScript versus 170 kilobytes of an image like a JPEG. So our network transmission time might be the same. So in this situation, it's 3.4 seconds. This is, I think they're actually doing that, the slow network and slower phone also. But then when we come to resource processing, it only takes maybe like 64 milliseconds for that image to decode, and then another 28 milliseconds for rasterize and paint. But when we come to JavaScript, after that bundle is delivered to the browser, we still have to do parse and compile. So in this situation, it took like about 2 seconds for parse and compile, and then another 1.5 seconds in execution. So JavaScript is your most expensive asset. So if you're looking byte to byte, JavaScript is going to be the most expensive, and the one you should probably worry about the most in terms of performance. So in case you just leave for the rest of the presentation, I'll tell you the TLDR now is just to ship less code. So less code is not only less load time, but less parse, compile, and eval time. Just less code. So the rest of this presentation is mostly about less code. Of course, your holy grail is to prioritize only what's needed in view. And this is also what some of the other speakers started talking about, like above the fold, progressive rendering. And we're going to talk about this a little bit more. And then you can lazy load the rest. It's funny, when it goes on the big screen, sometimes it doesn't look the same. So people talk a lot about like server-side rendering. So we're going to talk a little bit about client versus server versus progressive rendering. So this is an example of client-side rendering. So maybe your HTML arrives. Let's see if my little highlighter thing will work. Ooh, it does. But where is it? Oh, here it is. So maybe this is when HTML arrives. I just realized it's kind of small, so I'm pointing at it. But then you're just waiting there, right? Like the user's waiting there. They can't actually see anything yet. And finally, the JavaScript arrives, and it's evaluated, and it's rendered. So you have this wasted time. And that's that frustration of the user just being frustrated because it's taking so long to load. They can't see anything. Nothing's happening. So that's annoying. That's like your traditional. In the old days, it wasn't client-side rendered, right? Everything was server-side rendered. But now we have our frameworks and stuff, and we're rendering on the front end. So now we switch to clients. There's server-side rendering. So we moved up the time of when the HTML arrives and the view is painted. But then it might still take a while for JavaScript to arrive and being parsed and eval. And so then you have this, what Paul Lewis called this uncanny valley. And this was also that video earlier. Remember when you're like clicking and clicking, you can see the things, but they're just not working. So it's this time of frustration for users when they see something and they expect it to be working. And so that's annoying as well. So maybe instead of focusing on client versus server-side rendering, we should really focus on progressive rendering. And this is that idea that I ship my HTML, but then I only ship as much JavaScript and images that's immediately needed for the view that I can see at the moment, the above-the-fold content. And then you can lazy load images or additional features after that. And then even after that, load additional routes, depending on what they're most likely to use. Oh yeah, this worked again. So how do we optimize time to interactive? This is that load time or time to interactive. Well, remember, I want you to analyze your loads and bundles. Don't over-optimize. Don't make more work for yourself. Do the things that have the most impact. Only ship what's immediately needed. So use code splitting, pre-caching, and lazy loading. So code splitting is when we have multiple bundles that we can ship to the front end. Also, we used to ship like one giant bundle, but now with HTTP2, we can actually do a lot of concurrent requests for files. So if we do multiple smaller files, they'll actually load faster, and then we can parse and compile them faster as well. Pre-caching and resource hints, Patrick talked a lot about that earlier. And then lazy loading, for example, images that are further down the page or future routes. Minification. I know it's like an obvious thing that most of us do, but it doesn't just speed up your download time. They've actually measured it, and it also speeds up your parse and compile time. So don't forget to minify. And then, of course, compress. Compress with gzip or even better, Brotli. And then removing unused code. So tree shaking. Does everyone know what tree shaking is? What happens when you shake a tree? When you shake a tree, the leaves fall down, the dead leaves fall down. So we want our dead code to fall down and not be in our bundles. So there are ways you can do some of this automatically, but then there's things that you still need to keep in mind. And what's so awesome was I checked Twitter right before I came on here, and Manny had like the same, he had like a tweet exactly about one thing I'm about to show you. And here's like, finally there's some code in the presentation. Because I feel like I don't know why it's so important, but a lot of people don't know this yet, so that's why I'm doing it. So like, for example, Lodash. If you import underscore from Lodash, what are you importing? The entire Lodash library. But you're probably not using the whole Lodash library. Some people think if you then do import curly brackets, sorry, I should have shown this, is empty from Lodash, that's smaller, but that also imports the entire library of Lodash. So the way to only import that one function that you need is to do import is empty from Lodash / is empty, and then you can use it. Similarly, how many of you use Moment for like date time management on your front end? Don't worry, I use it too. But it's another one of those huge libraries, right? And also the internationalization stuff makes it even bigger. There's a way to make it slightly smaller, but there is a newer library for date and time management called datefns that is trying to be more functional like Lodash. And so now you can import only, for example, like add minutes from datefns / add minutes. So definitely look at that. They don't have quite all the functionality that Moment has, but I've started using it and to try to make my bundles a lot smaller. So this is one aspect of tree shaking that you kind of have to do yourself. And there are some other tools for doing it with Webpack or Prepack, whatever bundler you like. So this is a topic I'm really excited about. Jeremy Wagner had a name for it, and I forgot what the name is. But there's a cost to unnecessarily transpiling. So most of us, most of our users are actually on modern browsers. But we're still shipping like ES5 code. So ES5 code is bigger and slower. So there's a way now you can actually ship multiple bundles to your front end. So if you do script type equals module, modern browsers will recognize that, and you can use ES6 or ES 2015 plus code in there. Because if it's a script that's type equal module, it's most of the features that you're using in ES6 will be in there, like arrow functions and stuff like that. So this is Philip Watson, who's another Google engineer. He profiled his blog website or web application, and when he, you can see the ES 2015 plus bundle, minified is less than half of his ES5 bundle. And then also the parse and eval time is about half. So it's pretty awesome. You can just cut that time in half just by providing a modern bundle for modern browsers. And then the older browsers will just have to use the old version. That's a little bit slower. When will we ever get rid of Internet Explorer? Oh, and Serge is going to talk about modules a lot in the next talk. But as my friend Devin, who's now an engineer at Netflix, says, most of your time is spent using the app, not waiting for it to load. So don't forget about the other performance stuff. So how can we optimize responsiveness? Well, one of the big things is just don't block the main thread. So what are some ways you can do that? Avoiding memory leaks, because there's garbage collection and composite execution. You can avoid long-running JavaScript, so chunk it into smaller pieces, and you can use like request animation frame, request idle callback, to just kind of push things out of the main thread. And then use up-to-date frameworks that, if you're using a framework, that prioritize user input. So like, for example, React Fiber, starting in React 16. I'm a React engineer, so I apologize. I don't have anything against the other ones. But they are now starting to prioritize user inputs over rendering. So like if the user clicks in the user input, they'll pause rendering so that we can manage that and users are still happy. And actually, I'll be honest, a lot of this stuff, I didn't mention service workers and stuff like that yet. But I do think a lot of tools now are starting to bring this inside the tool. Because it's not easy setting up some of these things. And most of us, we aren't going to be like a performance engineer, right? We just want to ship code so that our clients are happy. And so a lot of the tools, like, for example, Create React App or Gatsby, sorry, I don't know the equivalents in Vue and Angular and the others, but they're starting to bring some of these things and setting them up for you in the tools themselves. So there's a way to cheat a lot of this. So I have another story for you. Does anyone know about this story about Houston's baggage claim complaints? No? Okay, good, yay. So Houston Intercontinental Airport, they used to have a ton of complaints about baggage, like, sitting there and waiting for baggage. And they spent a lot of time trying to get up to industry standard, which I think is like something like 8 minutes, like waiting for your time, or waiting for your baggage to come out. But after they did that, what do you think happened to the complaints? Did they go down? They did not go down. So the time went down, but the complaints did not go down. And so what they did is they observed, and they were like, what makes us different from other airports? And they looked and they observed, and what they realized was that the walk time from the gate to baggage claim was exceptionally short in Houston. So how do you think they solved this baggage claim complaint problem? So maybe this is the gate, this is baggage claim, right? So what they did was, so I'm at the gate, and I was like, so they did this, right? And you're like, are people happy? You would think they would not be happy. The complaints went away. Or, they went down. They probably didn't go away, because, right, no airport baggage experience is that fun. I can't see my notes anymore, but this MIT researcher basically said, the psychology of the wait is more important than the wait time itself. So, unoccupied time, that if you're just sitting there waiting for your bags, is, way more painful than occupied time. So are you better off making the site load faster or ensuring that users complete their tasks? This study is a little bit old, but Christine Perfetti, she worked on this study about download time. And they basically took the top 10 websites in 2006, and they asked users which one was faster, right? And the users were very consistent. They're like, these websites were really fast, and these websites were really slow. And when they measured the actual load times, it was almost the opposite. The top website that was fast was actually the slowest load time. And one of the slowest websites, or the fastest websites for actual real load, was actually ranked lowest by users in terms of slow or speed. So when it comes down at the end of the day, performance is very important, but I would still say that user experience and your users being able to get the job done that they're trying to do is still going to trump performance itself. So don't forget about the core of your application and what you're trying to do. Help your users get done what they're trying to get done. And the perception of performance will be even higher than probably your relative actual performance. So, thank you. My slide. So if you go to, because my name is really long on GitHub, so I made this bit.ly link, bit.ly CS Speaks, SIA, I'll put it in Slack also, and tweet it. But that's where, it's actually all my presentations, but you'll find a link, and it's like a gist, and it has like all of these kind of resource links, or how to know more, or just sources, but also the slides themselves.
Let me ask a question, if I may.
Yes.
So all this talk about bundling.
Yes.
Want to get excited about it. When should I stop bundling?
When
or
should
should
you
I?
stop bundling? Yeah. That's a good question. So I would say, oh yeah, you got it. Don't stop bundling, because for me, like I'm not opinionated, I use Webpack, but for me, bundling actually makes my development experience better. We bundle because we like using modules. We like organizing our code and having separate files for these things so that we can mentally organize them. And so to me, yes, you still bundle, but just thinking about how you bundle better for performance as well, like the setup of it, not just how you use it. But yeah, don't stop bundling, at least yet.
Thank you.